problem solving using the following theorems. Line parallel one side of a triangle intersects the other two sides to form a similar triangle to the original one. That is, triangle ABC is similar to triangle ADE because BC is parallel to DE and intersects sides AD and AE. The second theorem is when it intersects these other two sides, right, they are divided into given ratios. That means point B divides side AD in a ratio that is AD over BD. Point C divides side AE in a ratio AC over CE. But these two ratios are the same. Now, let us look at this problem. In the diagram, we have A, G, H is drawn. F and C are points on the A, G, that is F and C, respectively, such that AF is equals to 20, FG is equals to 15, CH is equals to 21. D is a point on FC such that ABC, right, is a rectangle with A, B, also parallel to GH, right? The diagonals of the rectangle ABCD intersect at M. That means here, that's where they intersect, right? So we want to calculate with the reasons the length of DM, right? So in this case now, if we are to separate the givens, we are simply saying we are given measures of parts of sides of triangle AGH, that is AGH, right? Rectangle ABC, we are given, and AB, right? Also parallel to GH. And I've underlined the word also, it has some meaning. And what is the meaning? Because in a rectangle, definition of a rectangle, opposite sides are equal and parallel, right? So when they say also, they are simply trying to make sure that you focus on remembering that the definition of a rectangle, opposite sides are parallel and equal, right? Now, when we now want to brainstorm the solution to our problem to find DM, right? We simply want to think of what is it that you are supposed to think about as our starting point. The given measures of parts of triangle AGH suggest proportion because we have the 20, we have the 15, we have the 21, and that shaded triangle, obviously you have to think about proportion because of that, right? So think in terms of triangles and parallel lines relations and similar triangles, right? So from the diagram, guided by what we want to calculate, we want the length of DM. You should recall, because we are told that this is a rectangle, ABCD is a rectangle. And what is it that we should remember? Opposite sides are equal and parallel. Diagonals are equal and bisect each other, right? These are the major properties of a rectangle that you are supposed to remember so that they will help you to solve this problem. Then you also realize that if you look at FC, FC should be parallel to GH. Why? Because DC is parallel to AB, definition of a rectangle. So FD is just an extension. So FC is also parallel to what? To GH, right? But then if you look at the triangle AGH, right? If FC is parallel to GH, then obviously the sides AG and AH are going to be divided into a given proportion. This is all what we are saying. They are parallel and intersect the other side of triangle AGH proportionally, meaning we have this proportion, right? C, again, since FC is parallel to GH, we know that the triangle formed AFC, right, should be similar to AGH, right? So this is what is there. So that at the end, if that is what we are given, we can establish this, because for any similar triangles, their sides are in a given proportion, which is this one. Right. Therefore, we use theorem in B, right, where we have the proportion with respect to given two sides, right, or a pair of sides, two pairs of sides rather. Then C, the issue that we are saying the given or the triangles AFC and AGH are similar, then we can start from there as we try to find our AC. Why finding AC? Can you see that AC is the diagonal of the rectangle and DB is the diagonal of the rectangle? According to the properties, diagonals are equal. That means if I find AC, the AC will be the same as DB. And again, they bisect each other. That means DM is equal to MB, or is equals to MC, or is equals to MA, right? So now I almost have the solution to the problem. Then what I simply need to do is to carry out the working. So method number one, using proportional theorem. That is starting from the fact that the point F will divide side AG into a ratio, then point C, A, H into a ratio, and those ratios are equal because FC is parallel to GH. That is our starting point. Then from there, we need to now substitute for the known values. After that, we then do our cross multiplication, because this is an equation in AC, one variable we are solving for AC. Then we go on to do some algebra. Then AC is equals to 28. Then for our required DM, we simply divide 28 by 2, which is equal to 14. Since AC and DB are equal and they bisect each other, therefore, we are through with this problem. Let's go to method number two. Now I'm going to use the triangle AFC similar to AGH, right? So with that, I can establish, because my side I want is AC. So these are the two sides I'm going to find their proportion. So I'm saying AF over AG, the bigger triangle, is equal to AC over AH, right? Because the two triangles are similar. Then from there, I substitute what I have, but you notice that I don't have AH, I have CH, but I can write AH in terms of AC plus CH. This is exactly what I did here. Then I substitute for CH, which is 21. Then this equation is a linear equation, and the variable is AC. Then I have to solve for the AC there by cross multiplication, that is cross product. Then it reduces to this. Then from there, you do some algebra. Then at the end, 84 is equals to 3AC. From there, your AC is 28 as before. Then you divide by 2 to get your DM. So as such, what is important is analyze the problem, understand it, think of what information you are given and what does that same information suggest to you.